Hello. Thank you very much for having me, and thank you very much for the introduction. My name is Nauya. I come from the Google Cloud team, and today I'd like to share with you how Google is using AI and machine learning. So, very interesting slides, especially the one from last night, which I kind of recall. How many machine learning-based predictions of last night's match actually could predict the excitement? A little depressed, but it was a very good game. Okay, so let's talk about this. So I'd like to step back a little bit in the beginning. From the business perspective, where AI and machine learning is kind of having a role. We hear this theme across industries, across businesses, that you want to move faster, or you're expected to move faster from your business counterparts, from your customers, from your users. And what that really means is that you really want to make smarter decisions faster. And to do that, you have to use a lot of data, get the most out of it. And the way you do that is you have a hypothesis, you want to test that, you want to prove that, and you want to really close this cycle, iterate quickly, and then gradually you move into that state where changing, moving faster, smarter becomes the norm. And I purely think that machine learning or AI is one of the technology elements that can really contribute to this. Well, today is a little bit more of a technology session, and I'd like to cover these topics. But before getting started, how many of you consider yourselves as pro machine learning experts? Just to get a sense. How many of you actually build models? A few? How many use machine learning models? And how many of you just want to learn about what it is? Okay, thank you very much. I just wanted to get a sense. So I'll quickly go into, at a very high level, what machine learning actually can be thought of. And then I'll introduce some of the highlights from recent research. At Google, we have an organization called DeepMind. There was a video shown earlier today that is really about pushing the boundaries of what can be done. How can we do things at the next level? And next, I'll be talking about how we are actually using those technologies, those outcomes of the research, into our services, products. Through that, we've gone through a lot of learnings. We had to go through some breakthroughs, and we'll talk about some technology innovations. And then, finally, how we are making that available to all of you so that you can also use the tooling or the experience that we've been building. Okay, so machine learning. Nowadays, with the keyword machine learning, you can get a lot of people to come to listen to you. There's definitely a lot of interest, but what actually is? And I think this word kind of explains it very well at the high level. It actually is a new way of programming. In the past, if you were a developer, you would write code, you'll write rules to tell the machine what to do. With machine learning, data is the new way to program the machine. It's the data that defines how the model reflects to new data. Right? And this paradigm shift is huge. And by doing that, things that are really hard in the previous model, where you had to write code, for those of you who write code, writing if then else, looping, all these things, you combine them and then tell the machine what to do. But with machine learning, you don't have to do that. You give example, and the machine learns by examples, or learns from the constraints, what works, what doesn't, and actually come with an outcome, which is a model that behaves based on that given data. And thanks to that capabilities, now we can identify things that were hard by writing rules. For example, by looking at an image of rice, how would you write a rule to know that this is rice? by getting an audio stream, how can I tell what this is actually talking about? All this content that was hard to absorb has now become easier to absorb, which is giving a lot more data points to whatever application you're trying to build. So at the cutting edge and the research side, so DeepMind is just one of the organizations. I'm going to introduce some of the things. Anyone know this game? It's a very old Atari breakout game. Well, a lot of these algorithms starts by applying algorithms to a game. Can a machine learn how to play? And this is more reinforcement learning. But you can see, yeah, now the application or the algorithm who is actually moving this board is getting a sense of how to move it, what works. And then eventually it learns pretty well. Moves faster, reacts faster, and get the results. This is where I learned that the team working on this went to lunch. And they just left the machine learning. And when they came back, this is what happened. So this is beyond human, right? By learning from what works and what doesn't, simple rules, and using the computation power to apply that to actually figure out, this algorithm enhanced itself with data. Another few examples. This is an algorithm that is trying to learn how to walk or how to crawl. Doesn't it resemble a baby or a small kid? I have a small kid. But in the beginning, it really looks like this. But it's amazing. It's not that it's coded to move like this. Based on given constraints, constraints mean that, in this case, more like physical connections of these sticks, gravity, and then you can actually learn. And this is powerful because it means that you can have a generalized model or algorithm that can learn from the constraints. And many of you have probably heard about AlphaGo. This was a game that was not easy to beat for a computer by just brute force calculation of all the combinations. The number of zeros that you see here, it's 172. I don't even know how to call it. But yes, but these enhancements that we see in the research have been amazing. Another concept that I really think is interesting is that this concept of AutoML. Machine learning has started to be generated through machine learning. And machine learning generating machine learning has started to get better results than machine learning curated or built by specialists. This graph shows one of the image recognition models comparison. And this red line is AutoML, the machine-generated machine learning. And you can see that it's getting to a better accuracy, and even with a less number of data. And it'll be interesting to follow how this evolves over time. So let's talk a little bit about how Google is adopting these things. Google's mission statement is to organize the world's information and make it useful to the users. And machine learning nowadays has been used everywhere. AI first, as was mentioned, is become the norm statement or the mindset when it comes to building applications. This graph shows statistics from our internal source code repositories, how many machine learning models have been built over the years. And it shows a spike, a growth from 2014-15. And a Google core team, called the Google Brain team, this is when the team has been building best practices, tooling, frameworks, so that other engineering teams can easily adopt machine learning. You've probably heard about Google Home or the assistant on the devices. Or you might be using Google Photos. In Google Photos, you take a photo, it gets uploaded. It's not just that. You can search for photos by just putting names like a beach, a boat, and the service knows what was in the photos. You no longer have to manually cluster or label the images, and that is because the machine learning models can detect what's in there. The assistant, this is more about voice, but how many of you use voice for your phones? The number of hands shows the generation range. The younger, it tends to be that you're not hesitant to talk to the phones and let it do things. But yes, it gives intuitive interface. Even Gmail, the email responses, now the first response can be generated so that you can just tap. Ease of use, quicker response. Now we're even generating more of a full sentence so that as you type, auto-completion works. Again, the machine learning has been learning how people write words, write a sentence, and thus can kind of detect what is the likely next options and give a lot of assistance to the users. And translate, I cannot live without this. But by combining different types of model, now we got to build a lot more interesting applications. This is a combination of many models. For example, the Google Translate application, you can look at the signboard. There can be a model that is going to detect the signboard. There's a model that's going to extract the text. There's a model that's going to do that translation. There's going to be a model that detects the font because you want to put that into the same visuals. And there's going to be a model that's going to morph that text into the original and even convert to speech. And over. Some interesting examples that you might not be aware of is that we're also running machine learning models in our data center, but we are also giving control, partially, of our data center to machine learning models. This is a graph where, as an experiment, we gave control of the knobs of the data center to a machine learning model. The optimization it can provide from all the data that we had collected has given a big amount of cost reduction. And this is from the recent Google I/O.
Assistant, more visually assisted.
So Google I/O is an annual developer event. It was mentioned, and the Google Duplex was one of the highlights from this year. And I wanted to just share with you one of those videos from a scenario.
Sensing when to respond with voice, and thank you.
Thanks, Lillian. It's great to see the progress with the assistant. As I said earlier, our vision for our assistant is to help you get things done. It turns out a big part of getting things done is making a phone call. You may want to get an oil change schedule, maybe call a plumber in the middle of the week, or even schedule a haircut appointment. We are working hard to help users through those moments. We want to connect users to businesses in a good way. Businesses actually rely a lot on this, but even in the US, 60% of small businesses don't have an online booking system set up. We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
So how can I help you?
Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd.
Sure, give me 1 second.
Too real.
Sure, what time are you looking for around?
At 12 p.m.
We do not have a 12 p.m. available. The closest we have to that is a 1:15.
Do you have anything between 10 a.m. and 12 p.m.?
Depending on what service she would like. What service is she looking for?
Just a woman's haircut for now.
Okay, we have a 10 o'clock.
10 a.m. is fine.
Okay, what's her first name?
The first name is Lisa.
Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd.
Okay, great. Thanks.
Great. Have a great day. Bye.
So this is amazing. Now technology can interact with a person in a human conversation and it's actually making an appointment for you. And think about outbound calls that you do as a business if you can automate that. But this also poses a question. And this is becoming another question in this domain. Should we actually do that? And technology is becoming so powerful, there's a lot of things that you can do. But if you think about it, the opposite side didn't know it was a machine. Was that right or not? Is it ethically correct or not? And these are the questions that people are starting to ask more as the technology advances. Others will be biases, gender bias. There's different biases that we want to neutralize as much as possible. For machine learning, the world that the machine learning knows is the data that is given, right? So if your data is biased, that's going to be reflected. How can we neutralize that within your data? And all these things has been leading Google to set this AI principles. What is the right things that we can apply machine learning, or what are the things that we should not? If interested, please have a look. It is very interesting, and I'm very proud for this to be shared outside to the world. So that was part of what we do. And throughout that, we have gone through some innovations that we also like to share about. So general tough challenges in machine learning is that first, to do a more sophisticated machine learning, you might need a lot of data. And to crunch that, you might want to have a lot of computation power. But you also need to have a good model or algorithm. So computation for Google hasn't been that much of a problem. We've been running a lot of data centers. We have a lot of machines connected with a huge network. But on top of that, we need to do something to make it easier to turn these machines into something that we can use for machine learning. And one of the inventions has been TensorFlow. How many of you have heard about it or used it? Thank you. So if you are to start machine learning today, TensorFlow is a great framework to get started with. And the reason is it's designed to scale. It's designed to run everywhere, and it's designed to be distributed. And at the core, this is a C++ implementation that makes it really fast. But we also have layers of abstraction so that you can run it from Python, from other languages. And it's not just for neural networks or machine learning. Whatever algorithms, whatever numerical computation, you can apply this. So it's a very general purpose library that is great for many use cases. And it gets the acceleration it needs when run on certain environments. If you are a data scientist, you might be experimenting in your laptop. It's run there. You might want to have a bigger server in your data center. It runs there. You might want to get acceleration through GPUs. You can use that. And at Google, we also invented dedicated hardware that even gives more acceleration. On the other side, if you want to run it in a mobile application, you might want to be able to shrink it down and run it in there. It supports that. And even more, we're adding support to run that in the browser as well. This is a machine learning doing some clustering in the browser. Very fast. The language is JavaScript. That means web developers can easily use this. And this is open up more applications of machine learning. Well, throughout these years, this is some of the features that machine learning, TensorFlow has been releasing, but it's been great getting a lot of adoption. The community is building, and I hope you get to use these and also contribute so that we can collaborate in the open source space. With all those technologies, what we are doing is trying to make the technologies that we have built available to everyone. We do provide, as a Google Cloud team, an infrastructure with the different hardwares that you can run your programs. We also give you the direct integrations with TensorFlow, automated TensorFlow environments, so that you don't have to build a machine, build a server set to actually run these. You don't have to do the boilerplate to actually make this happen. We also provide a high-level machine learning-powered APIs, translate, object detection, speech to text, text to speech, so that application developers, all they have to do is write a couple of lines of code and adopt the Google machine learning. On top of these, we believe that we have a platform that we can collaborate with all of you to build more of the business applications. And we'd love to have a talk with you, love to see where we can co-work, and love to have new innovations out of our platform. So with that, I'd like to pause, but myself, my colleague Chan is here, and if you have any further questions after this session, we'd love to handle.
ไม่มีใช่ไหม
If that's the case, I can take the questions offline, and with that, thank you very much.